Namaste dear children, I am Rekha. Welcome to my channel Rekha's Knowledge Hub. Today we will see NCERT Class 6 Science Chapter 8 A Journey Through States of Water. If it does not rain well, even the mighty ocean will be drained. This is a line from the ancient Tamil scripture Tirukural. Just like you need water to drink, the ocean needs rain to stay full. If it never rains, the ocean wouldn't get any new water. Just like a bathtub empties, if you don't refill it, the ocean could slowly shrink if it never gets any rain. So, the saying means that the rain is very important for the ocean to stay big and full. On a bright summer afternoon, Avi and Thirav enjoy their shikanji, that means lemonade. After looking at the ice in the lemonade, Thirav wonders about the nature of ice and water. So, Avi and Thirav, they were enjoying shikanji. Shikanji means lemonade. Then, after looking at the ice in the lemonade, Thirav, he wonders about the nature of ice and water. What Thirav said? Ice feels hard to touch and we can hold it in our hands, whereas water cannot be held in the same way. So, they must be different substances. Thirav said, ice is very hard to touch. We can hold it in our hands, but water we cannot hold in the same way. So, they must be different substances. Ice and water, they must be different substances. Then what Avi said? No, they are the same substances. Avi has a counter view to Thirav. What do you think? Why? Avi said, correct. Ice and water are the same substance. Ice is the solid form of water, while water is the liquid form. Ice is a solid form and water is a liquid form. We said we can put water in the freezer of a refrigerator and check if it gets converted into ice. You put some water in the freezer and check whether it converted into ice. Yes, I know. When water is left in the freezer, it gets converted into ice. But probably something gets added to the ice in the freezer. What Thirav said? Thirav said, when water is left in the freezer, it gets converted into ice. But something must be added to the ice in the freezer. Do you think Thirav is right? How can you find out? We will do an activity. Activity. Let us observe. Put an ice cube in a cup. Leave it on the table and observe. You put an ice cube in a cup. Leave it on the table and observe. What will happen? Ice gets converted into water. After some time, ice will convert into water. What can you conclude from the observations? Does this mean that ice and water are the same substance? Yes, ice and water are the two forms of the same substance. Ice and water, both are the two forms of the same substance. These forms are also called states. These different states of water show many differences in their behavior. Water flows, but ice does not. Water splashes, but ice does not. So, ice and water, they are the two forms of the same substance. These forms are called states. There are many differences in their behavior. Water flows, but ice does not. Water splashes, but ice does not. Investigating water's disappearing act. It is a rainy morning. While going to school, Avi and Thirav observe that there are a lot of water puddles in the playground. That evening, when they go to play, they are surprised to observe that some of the water in the puddles had disappeared. When they went to school in the morning, they saw a lot of water puddles in the playground. But in the evening, most of the water in the puddles had disappeared. Have you ever noticed water in the puddles disappearing? Where does it go? Discuss with your friends. What Tirav said? I think the water has been absorbed by the soil on the playground. What do you think about it? Tirav said, water has been absorbed by the soil on the playground. Where else have you seen water disappearing? Can you think of a possible reason why this happens? Why the water disappeared? You might have observed that after washing the utensils, water left on the surface of the utensils dries up after some time. That's the reason you thought earlier to explain water disappearance apply in this case also? When you wash the utensils, you can see some water on the surface of the utensils. But this water dries up after some time. Do you know the reason? Avi wonders if water has seeped through the surface of the utensils. Dhirav thinks that water does not seep through the surface of the utensils. That's an activity to investigate whose idea is correct. Avi wonders if some water has seeped through the surface of the utensils, then what Dhirav thought? The water does not seep through the surface of the utensils. Take a tablespoon of water on a steel plate as shown in figure 8.1. See this figure? Here there is a steel plate with a tablespoon of water. Observe whether water seeps through the other side of the plate or not. You just observe whether this water sweeps through the other side of the plate or not. Keep observing this at regular intervals until the water completely disappears. You have to observe this at regular intervals until the water completely disappears. What do you infer? Is this activity enough to come to the conclusion that water does not seep through a steel plate? Water does not seep through a steel plate. If water does not seep through the steel plate, then where has the water gone? This water gets converted into gaseous state called water vapor. The water vapor is another state of water. Let us think of another observation where you notice the water disappearing. So, in the case of this steel plate, where has the water gone? This water gets converted into gaseous state called water vapor. While making dosha, we sprinkle some water on the hot pan and it disappears. Where does it go? When you make dosha, we sprinkle some water on the hot pan, but it disappears soon. Where does it go? The water which is sprinkled on the hot pan gets converted into steam. The water gets converted into steam. Steam is actually water vapor, some parts of which converts into water droplets. So the water sprinkled on the hot pan gets converted into steam. Steam is actually water vapor. Some part of the steam converts into water droplets. The process of conversion of water into its vapor state is called evaporation. This is very important. What is evaporation? The process of conversion of water into its gaseous state, that is vapor state, is called evaporation. The process of evaporation takes place continuously even at room temperature. Can you think of other examples of evaporation? Can you say some examples of evaporation? Drying of wet clothes, mopped floor, sweat on our body are some examples of evaporation. When you hang wet clothes, the water in them slowly disappears. That's because the sun's heat causes the water to evaporate into the air. When you mop the floor, you add water to it. The water on the floor starts to evaporate. When our body temperature rises, our bodies produce Sweat. This sweat then evaporates from the surface of our skin. Now, what do you think is the reason for the disappearance of water from the puddles? Is it due to sweeping of water into the ground, evaporation of water, or both of these? What is your answer? Both 1 and 2. Some water sweeps into the ground. Also, water in the puddles evaporates due to the heat from the sun. Hand sanitizer disappears as you rub it on your hands. What happens to it? The main reason hand sanitizer seems to disappear is evaporation. Hand sanitizers contain alcohol, which is a volatile liquid. This means it easily changes from a liquid to a gas. When you rub the sanitizer on your hands, the friction from rubbing and the warmth of your skin increase the rate of evaporation. Another mystery. Next day, Avi, Tirav and their friends decide to make lemonade. Avi, Tirav and their friends decide to make lemonade. During the preparation, they take cold water in a glass tumbler and add ice cubes. So during the preparation, they take cold water in a glass tumbler and add ice cubes into it. After a few minutes, they notice something exciting about the outer surface of the glass tumbler. Let us find out by conducting a similar activity ourselves. Let us experiment. Take cold water in a glass tumbler, add a few ice cubes into it. See this figure 8.2, a glass tumbler containing cold water and ice cubes. Leave it undisturbed for 5 minutes and observe it. So observe it after 5 minutes. Record your observations and the questions that arise in your mind in table 8.1. You can also touch the outer surface of the glass tumbler to feel if there is any change. You may have many observations and questions here. One observation that arises in Avi's mind is there are some water droplets or tiny drops appearing on the outer surface of the glass tumbler. Initially, water droplets are deposited and these droplets combine together to form bigger drops. You can also try the above process with a metal container. You may be curious about where the water droplets come from. So after some time, you can see some tiny drops of water on the outer surface of the glass tumbler. Initially, water droplets are deposited and these droplets, they combine together to form bigger drops. Where the water droplets come from suggest possible reasons explaining the appearance of water droplets on the outer surface of the glass tumbler. Discuss with your friends, write down the possible reasons. Maybe ice has come out of the glass tumbler and melted. See, one child said, maybe ice has come from the glass tumbler and melted. You may have various possible reasons. You may agree or disagree with the reasons of others. Avi and Tirav argued with a chain of reasons. What do you think about the possible reasons mentioned? You may have various possible reasons. You may agree or disagree with the reasons of others. Avi and Tirav argued with a chain of reasons. What do you think about the possible reasons mentioned in figure 8.4? See, there is a chain of reasoning. Avi said, I think that some of the water may have seeped out of the glass tumbler. Some water may have seeped out of the glass tumbler. Then Tirav said, no, it cannot seep out. Why? The level of water in the glass tumbler has not decreased. The level is same. So water cannot seep out. Again Avi said, it might have decreased but may not be significant enough to be seen. It might have decreased but it may not be significant enough to be seen. With a tall and narrow bottle, even a slight change in the level of water is noticeable. What Tirav said? The glass tumbler is tall and narrow, so even a slight change in the level of water is noticeable. We can take water at room temperature in another tumbler and find out whether any water seeps out. We can then check with another tumbler. Continue the discussion on the given reasons or conduct activities to find evidence for the reasons given to help in this discussion. Where else have you seen water droplets like this? Have you seen water droplets like this anywhere else? You might have seen dewdrops on plants. On plants, you might have seen dewdrops. Why do we see dewdrops more in the morning? Why? You can see more dewdrops in the morning when we boil the water in a half-filled utensil and cover it with a steel plate. Some water drops accumulate on the inner side of the steel plate. Where do these water drops come from? What do you think? So, when you boil water in a half-filled utensil and cover it with a steel plate, after some time you can see water drops accumulate on the inner side of the steel plate. So, when the water vapor present in the air comes in contact with a cold surface, it forms water droplets. This process of conversion of water vapor into its liquid state is called condensation. This is very important. What is condensation? When the water vapor present in the air comes in contact with a cold surface, it forms water droplets. So, this process of conversion of water vapor into its liquid state is called condensation. After understanding the concept of condensation of water, let us go back to activity 8.3. Could the water appearing on the outer surface of the glass tumbler in activity 8.3 also be due to condensation of water vapor present in the air? See, the air around us always contains water vapor, which is an invisible gas. When you place cold water in the glass itself cools down. The cold surface, glass surface, cools the air in its immediate vicinity. When the air temperature drops, the water vapor in the air loses energy and changes its state from gas to liquid. This process is called condensation. The condensed water vapor forms tiny droplets on the cold surface of the glass, which you see as sweating or condensation. Let us measure. Avi and Thirav conduct an activity to find evidence for their reasons. You can also conduct the activity by following the steps given below. Take a glass tumbler half filled with water containing a few ice cubes. You take a glass tumbler half filled with water and you add some ice cubes. Cover it with a small steel plate. Weigh it on a digital weighing balance. Observe the reading on the balance and record the weight after every 5 minutes. You observe the reading on the weighing balance and record the weight after every 5 minutes. Continue observing for 30 minutes. Record your observations. Predict what will happen to the mass of cold water kept on the digital weighing balance. Will it increase or decrease or remain the same? So you have to check whether the mass of cold water will increase or decrease or will they remain the same. See this table, measurement of mass in condensation experiment using a digital weighing balance. At time 0 minutes mass of water 200 gram, after 5 minutes 200.2 gram, after 10 minutes 200.5 gram, then after 15 minutes 200.8 gram, after 20 minutes 201.0 gram, then after 25 minutes 201.3 gram, after 30 minutes 201.5 gram. See here the mass of water is increasing. The amount of water vapor in the air is also known as humidity. So what is humidity? The amount of water vapor in the air is called humidity. You may observe some water droplets on the glass tumbler. Water vapor from the air comes in contact with the cold surface of the glass tumbler and gets converted into water droplets on the glass tumbler through condensation. So, why you observe some water droplets on the glass tumbler? Because water vapor from the air comes in contact with the cold surface of the glass tumbler and gets converted into water droplets on the glass tumbler through the process of condensation. There is an increase in the reading on the digital weighing balance. Can we conclude that water is not seeping through the wall of the tumbler? Can we also conclude that the water collected outside the tumbler is only due to condensation? No, we cannot say that conclusively. From activity 8.4, what more can you do to show that the water is not sweeping from the glass tumbler? How would you modify activity 8.4 to find the answer? Repeat activity 8.4 with the following modifications. Mark the water level on the glass tumbler with a permanent marker or a visible tape. What do you observe? Water level in the glass tumbler does not go down, but the extra water gets collected on the outer surface of the glass tumbler. What can you conclude from this? This activity shows that water is not seeping from the glass tumbler and the extra water is getting collected because of condensation. Why the mass of water increased? Water is not seeping from the glass tumbler. But why the weight is increasing? Why the mass of water is increasing? Because extra water is getting collected because of condensation. What are the different states of water? Water is a substance that can be observed in three different states in our daily life. In the solid state, it exists as ice. On heating, ice melts and gets converted into its liquid state. On further heating, water gets converted into its gaseous state. Let us perform activity 8.5 to identify the properties of different states of water. So, water exists in three different states: solid state, liquid state, and gaseous state. In the solid state, water exists as ice. On heating, what happened to ice? The ice melts and gets converted into its liquid state. Then, if we heat further, water gets converted into its gaseous state. So, solid form is ice, liquid form is water, gaseous form is water vapor. Let us identify. Put an ice cube in one container and transfer it to another container of different shape. What changes do you notice in the shape of the ice cube? So, first you put an ice cube in one container, then transfer it to another container of different shape. Then you observe the ice cube, shape of the ice cube. Next, you pour some water from one container to another container of a different shape. Observe how water behaves compared to the ice cubes and make a record. Did you notice how water flows from one container to the other? What happens to its shape? So, in the next case, you pour some water from one container to another container of different shape. Then you observe how water flows from one container to the other. Also observe what happens to its shape. Then pour water on a clean surface and observe how it spreads. When water gets converted into water vapor, how does this water vapor spread? Compare this with the spreading behavior of water. You pour some clean water on a clean surface and observe how the water spreads. Then again, when water gets converted into water vapor, you check how does this water vapor spread. See this table, compare different states of water. See the property, shape, ability to flow, then ability to spread. Ice is a solid state of water. See, what about its shape? Fixed shape. Ability to flow? it does not flow. Ability to spread, it does not spread. Then its liquid state is water. What is its shape? It will take the shape of the container. Then ability to flow, flows easily. Then ability to spread, spreads in the container. Then gaseous state is water vapor. What is its shape? No fixed shape. Ability to flow, flows freely. Ability to spread, spreads any available space. So what are the differences in the properties of water in solid, liquid and gaseous states? See, ice. Ice is a solid state of water. Ice retains its shape irrespective of the container in which it is placed, while water takes the shape of the container. Ice does not flow or spread. So, ice, it retains its shape irrespective of the container in which it is placed. But water takes the shape of the container. Ice does not flow or spread. Then, what about water, the liquid state? It flows and changes its shape. Water does not have a fixed shape. It takes up the shape of the container in which it is kept. But the volume of water remains constant. See, the volume of water remains constant, but what about its shape? It takes up the shape of the container in which it is kept. Does water also possess the property to spread? Yes, water also has the property to spread while keeping the volume constant. Volume remains same, but it has a property to spread. Water vapor, gaseous state, exhibits a property of spreading out in the entire available space. So, the gaseous state of water is water vapor. It spreads out in the entire available space. Then, what about its shape? Gases do not possess a fixed shape. They do not have fixed shape. Water vapor exists even at room temperature, though it is invisible to us. Why water vapor exists even at room temperature? Because water vapor is present in the air around us. It is present in the air around us. The water that evaporates during process like drying of clothes or mopping of floors contribute to the water vapor in the air around us. So, water vapor exists even at room temperature. You are now familiar with the three states of water: solid, liquid and gas. Some other substances also exhibit these states, for example, wax, oil and ghee. Let us look at some more examples of solids, liquids and gases. Look around and find some examples of solid substances. Some examples could be stones, wood and glass. They are solid substances. What are the other examples of liquids you can think of? Here are two examples, milk and oil. Think of five more examples: coffee, honey, mercury, blood, then alcohol. All these are liquids. Have you ever noticed that you can smell the food being cooked even without entering the kitchen? How does this smell reach us? So without entering the kitchen, you can smell the food being cooked. How? It is because the smell of yummy food from cooking spreads through the air and reaches our nostrils even if we are not in the kitchen. So even if we are not in the kitchen, the smell of yummy food from cooking spreads through the air and the smell will reach our nostrils. What are the other examples of gases you can think of? What about oxygen and carbon dioxide? See, hydrogen, nitrogen, oxygen, carbon dioxide, carbon monoxide, all are gases. How can we change the states of water? So far we have learned that water can exist in solid, liquid and gaseous states. How can you change the state of water? So water exists in three states: solid, liquid and gaseous state. How can you change the state of water? How can you quickly change ice to its liquid state water? How can you change ice to its liquid state water? Ice is the solid state. How can you change ice to liquid state water? If we have to change ice into water and water into water vapor, we have to supply heat to it. So if you want to change ice into water or water into water vapor, we have to supply some heat. If we want to change water into ice, what should be done? Suppose if you want to change water into ice, that is liquid to solid state, what should be done? It can be done by placing water in a cold environment such as freezer. Water freezes and is converted into ice. If we take the ice out of the freezer, it melts and is converted into water. If you want to change water into ice, place water in a cold environment like freezer. Then water will freeze and is converted into ice. If we take the ice out of the freezer, what will happen? It will melt and will convert into water. Can you think of any other example besides water that can change from solid to liquid? A candle. Candle, which is made of wax, is one such example. You can change from solid to liquid state. How can we turn candle wax into liquid state? Wax is a solid state. How can you change the candle wax into its liquid state? How can we change the liquid wax back into the solid state? We should cool the liquid wax to change it into a solid. So when you heat wax, such as by placing a candle over a flame, what will happen? The solid wax will melt to liquid. When you remove the heat source like the flame, the melted wax begins to cool down and you will get solid wax. What are the other liquids you have seen which get converted into a solid? Have you ever seen coconut oil getting converted into its solid state during the winter season? So during winter season, we can see coconut oil getting converted into its solid state. Hence, we can see the water and other substances change their states on heating or cooling. So substances, they can change their states on heating or cooling. The process of conversion of a solid into liquid state is called melting. The process of conversion of liquid into solid state is called freezing. So what is melting? The process of conversion of solid into liquid state. Then what is freezing? The process of conversion of liquid into solid state is called freezing. Let us check the connection between different states of water through activity 8.6. Activity. Let us complete the diagram. Fill up the blank boxes in figure 8.5 marked as A, B, C and 1, 2, 3, 4 for conversion of different states of water using the words given in the box. 2 words have been filled for you. Say, first one, melts. Solid melts to form liquid. Liquid evaporates to form gas. Gas condenses to form liquid. Then liquid freezes to form solid. See, atmospheric water generator AWG. So, atmospheric water generator AWG machines collect water from humid air to produce drinkable water. So, atmospheric water generator machines, they collect water from humid air to produce drinkable water. This is done through condensation of water vapor by cooling the air. This process is similar to the Formation of drops of water outside the glass tumbler filled with ice cold water. How can water be evaporated faster or slower? In section 8.1, we have learned about evaporation. Let us explore it more. Observe your surroundings. What are the conditions that affect how fast water evaporates? What differences do you see in evaporation on a cold day versus a hot day? Discuss with your friends. The following words may help in your discussion: fan, drying cloth, sweating, windy day, hot day, rainy day. Let us perform activity 8.7 to investigate conditions that will affect how fast water will evaporate. So, what are the factors that affect how quickly water evaporates? See, temperature. What will happen at higher temperature? Faster evaporation. Think of how clothes dry faster on a hot sunny day. Then what will happen at lower temperature? Slower evaporation. Clothes take longer to dry on a cold cloudy day. Then humidity. If humidity is low, evaporation will be faster. When the air is dry, it can hold more water vapor, allowing water to evaporate more quickly. If humidity is high, evaporation will be slower. When the air is already full of water vapor, it cannot hold as much, slowing down the evaporation process. Then, wind or breeze. If there is wind or breeze, then evaporation will be faster. Why? Wind carries away the water vapor that has evaporated, allowing more water molecules to escape into the air. So, evaporation will be faster. Let us investigate. Take water in a small cap of a bottle. You may use sanitizer in place of water. Take the same amount of water in a plate. The exposed area of water in the bottle cap and the plate are different. Keep both of them near each other. Record the time taken for the water to completely evaporate in each case. So take water in a small cap of a bottle. Take same amount of water in a plate. The exposed area of water in the bottle cap and the plate are different. See, when the surface area is large, evaporation will be faster. Spreading water out over a large area exposes more of it to the air, allowing it to evaporate more quickly. See, the students are discussing what conditions did we keep the same? What did we change in this investigation? What did we measure? Findings of the investigation: exposed area of water, then time taken for complete evaporation. See, exposed area of water, if it is bottle cap, exposed area is less. So, time taken for complete evaporation is more than plate. Then, what about plate? Exposed area of water is more. What about time taken for complete evaporation? Less than bottle cap. What can you conclude from this investigation? If you spread out water on a plate, its area exposed to air is larger. When you spread out water on a plate, what about its area exposed to air? It will be larger. Therefore, evaporation is faster. What would happen if milk is taken instead of water in the above activity? See, milk would also evaporate, but it may leave a residue due to its other components which do not evaporate like water. Other conditions which affect how fast water evaporates. Design an activity similar to activity 8.7 to find out what are the other conditions which can affect how fast water will evaporate. What would you change? What would you keep the same? Perform this activity. Use table 8.5 to record the data and discuss your observations. Other than the conditions you have exposed to find how water can be made to evaporate faster or slower, you can also conduct activity 8.8 to explore is further. So what are the other conditions which affect how fast water evaporates? Temperature, humidity, then air movement, type of liquid, etc. See, temperature, if it is high, evaporation will be faster. If temperature is low, evaporation will be slower. Humidity, if humidity is low, evaporation will be faster. If humidity is high, evaporation will be slower. Then wind or breeze, if there is wind or breeze, evaporation will be faster. Wind carries away the water vapor that has evaporated, allowing more water molecules to escape into the air. Then also type of liquid, different liquids evaporate at different rates. Some liquids evaporate more quickly than others. Let us explore. Take identical caps of two bottles. Pour equal amount of water in each of the cap. Place one of the cap in sunlight and keep the other in shade. Observe the two caps of bottle. After every 15 minutes, record the time taken for the water to completely evaporate in each case. You can also repeat this activity on a windy or a rainy day and record your observation. So, take two identical caps, bottle caps, pour equal amount of water in each of the cap. Then place one of the cap in sunlight and keep the other in shade. Then observe the two caps of bottles after every 15 minutes and record the time taken for water to completely evaporate. What conclusions can you draw from activity 8.8 and other similar experiences? Water evaporates faster from the cap kept in sunlight compared to the cap kept in shade. So, water evaporates faster from the cap kept in sunlight when compared to the cap kept in shade. It is a common observation that clothes dry faster on a hot sunny day. Do clothes dry faster or slower on a windy day? It is once again a common observation that clothes dry faster on a windy day. With increase in the movement of air, water evaporates faster. This is very important. Our clothes will dry faster on a hot sunny day. When temperature is high, evaporation will be faster. Similarly, clothes will dry faster on a windy day. With the increase in the movement of air, water evaporates faster. It is also a common observation that clothes dry slowly on a rainy day. On a rainy day, water evaporates slowly. If the amount of water in the air is already high, more humidity, water evaporates slowly. So, the clothes will dry slowly on a rainy day. Why? On a rainy day, water evaporates slowly. If the amount of water in the air is already high, that is, if it is more humid, water evaporates slowly. The amount of water vapor in the air is more on rainy days and hence rainy days are more humid. The amount of water vapor present in the air will be more on rainy days. Hence rainy days are more humid. If you want to dry your clothes on a rainy day, how can you make it faster? You can use fans. Okay. Place a fan near your drying rack to circulate air around the clothes. Then you can open windows. If possible, open windows to increase airflow and reduce humidity. Then use a dehumidifier. A dehumidifier will remove moisture from the air, speeding up the drying process. Cooling effect. Avi's mother purchased a new matka. Matka means earthen pot to replace the stainless steel pot for storing drinking water. Upon returning from school, Avi notices the earthen pot and drinks water from it. Avi expresses surprise and asks, "Why is the water in the earthen pot so cold? I never observed water getting cold in a stainless steel pot. What do you think is the reason?" Avi's mother, she replaces the stainless steel pot with a matka or earthen pot for storing drinking water. The water in the earthen pot is so cold. Why? Water seeps through the surface of the earthen pot and evaporates, which imparts a cooling effect on the water. So, the reason is water seeps through the surface of the earthen pot and evaporates. So, this imparts a cooling effect on the water. These earthen pots, they have tiny pores in their walls. So, as water sweeps through these pores, it evaporates from the outer surface of the pot. This evaporation process requires heat energy. The heat needed for evaporation is absorbed from the water inside the pot, leading to a cooling effect. What are the other examples of cooling effect? Sprinkling water on the floor or the roof during summer to cool it is another example. So when water is sprinkled on the roof or floor, some of it evaporates. So evaporation is a process that absorbs heat from the surface it's happening on. So as the water evaporates from the hot roof or hot floor, it absorbs heat from the surface, floor surface or roof surface, helping to cool it down. How do you feel when you rub sanitizer on your hands? See, hand sanitizers, they contain alcohol, which evaporates very quickly. So when the alcohol evaporates, it absorbs heat from your skin. This heat energy is used to change the liquid alcohol into a gas. So this heat transfer from your skin to the evaporating alcohol creates that cooling sensation you feel. Let us perform activity 8.9 to observe the cooling effect by making a simple and electricity-free model of pot-in-pot cooler. Take two earthen pots of different sizes. You take two earthen pots of different sizes. Fill the bottom of the larger pot with a layer of sand. Take the larger pot, fill its bottom with a layer of sand. Then place the smaller pot into the center of the larger one. See, you can see the figure here. Fill the gap between the pots with more sand. Pour water in the sand area. So, you fill the gap between the pots with sand. Also pour some water in the sand area. Place a lid or wet jute sack to cover the top of the small pot. So, you have to cover the top of the smaller pot with a lid or wet jute sack. See, in this picture you can see wet jute sack. See, this is the small pot and this is the larger pot. You can also make a drawing of the pot-in-pot cooler once it is ready. Allow 4 to 5 hours for the mini pot-in-pot cooler to cool down. You have to give some time, 4 to 5 hours for the mini pot-in-pot cooler to cool down. The time range can be influenced by many conditions. Observe and discuss how it creates a cooling effect. Inside the pots, keep some vegetables and fruits in it and observe for a week on a daily basis. You have to keep some vegetables and fruits in it and observe a week on a daily basis to check for the freshness of the vegetables and fruits kept inside the cooler. You can check the freshness of the vegetables and fruits. You will have to add water regularly to keep the sand moist. So to keep the sand moist, you have to add water regularly. For how many days can the vegetables and fruits be kept fresh in it? What are the conditions which can affect the number of these days? What else can be used in place of sand for better cooling? You all may be familiar with this unique clay pot which is called surahi. In summers, surahi is used to keep the water cold. How do clouds give us rain? Condensation plays a significant role in the process of bringing evaporated water back to the Earth's surface. So, condensation plays an important role in the process of bringing back evaporated water to the Earth's surface. How does this happen? When air moves higher above the Earth's surface, it becomes cooler and cooler. At certain heights, the air gets so cool that the water vapor in it turns into droplets, which are generally formed around dust particles. These small droplets float in the air and form clouds. Many droplets join together to form bigger drops of water. Some drops get so heavy that they start falling. These falling water drops are what we call rain. So when air moves higher above the earth's surface, it becomes cooler and cooler. When reaching certain heights, the air gets so cool that the water vapor in turn changes into droplets, which are generally formed around dust particles. These small droplets float in the air and they form clouds. Many droplets they join together to form bigger drops of water. Some drops get so heavy that they start falling. These falling water drops are called rain. Under special conditions, it might also fall as hail or snow. Avi enjoys the rain and creates a poem. You can complete the poem and present it in your class, that you can do. Activity 8.10 demonstrates the role of dust particles in the formation of clouds. So we will see what's the role of dust particles in the formation of clouds. Let us engage in a group activity. Take an empty discarded 1 liter plastic bottle. So take an empty bottle, 1 liter plastic bottle. Pour about 1 cup of water into it. Then you pour 1 cup of water into that bottle. Close the lid tightly. Now quickly squeeze and release the bottle continuously for about 2 to 3 minutes. Observe the space above the water in the bottle. After closing the lid tightly, you quickly squeeze and release the bottle continuously for 2 to 3 minutes. Then repeat the same activity after adding a small burnt piece of newspaper into the water. Then repeat the same activity after adding a small burnt piece of newspaper into the water. What will you observe? In this case, you will observe some haziness. That means clouds above the water in the bottle. So, above the water, you can see some clouds in the bottle. The burnt newspaper provides very small invisible dust particles around which water vapor condenses and forms clouds. So why these clouds appear? Because the burnt newspaper, they provides very small invisible dust particles around which the water vapor condenses and form clouds. Let us perform activity 8.11 to represent our understanding of how water changes its state and its movement. Let us understand the process. Label figure 8.9 using arrows shown and the words given in the box to show where water is stored, how water changes its state and where it moves. See, you have cloud, lake, ocean, river, groundwater, evaporation, condensation, rain, and snow. The water from the ocean and the earth's surface evaporates into the atmosphere as vapor and returns as rain, hail, or snow, ultimately following back to the oceans. This circulation of water is known as water cycle. So, water from oceans, then groundwater, etc. They evaporate into the atmosphere as vapor, okay, and returns as rain or snow or hail, and then ultimately back to the oceans. The circulation of water is known as water cycle. Only a small portion of water available on the earth is fit for use by plants, animals, and humans. Most of the water is in the oceans and it cannot be used directly. We use water for drinking and also for many other activities. The number of people using water is increasing with a rise in population. The increasing demand for water causes its shortage in many parts of the world. Hence, it is very important to use water wisely and avoid wasting it. Let us keep our water bodies free from pollution. You will learn more about water and its conservation in the chapter Nature's Treasures. So, only a small portion of water available on the earth is fit for use by plants, animals, and humans. Most of the water is in the oceans. So, this water cannot be used directly. We use water for drinking, cooking, washing, so many activities. See, as the population increases, the demand for water also increases. So, this will result in shortage of water in many parts of the world. So, it is very important to use water wisely. We have to avoid wasting water. We have to keep our water bodies free from pollution. Children, thanks for watching. If you like this video, please like, share and subscribe. We will see in the next video. The playlist for various subjects are given in the description box. Please go through it. Thank you.